Hello, everybody. This is ST536, Fundamentals of Information Technology. I'm Rob Hepler. I've started you out here today, the picture of our hardware, this beast that's dumb as dirt. And I'm going to talk today about the system software, the operating system, if you will, the thing that makes it work, actually. Remember, this cold piece of metal, this machine I showed you, needs more so humans can talk to it and make it work. Remember, it's a tool like anything, like a hammer. We've had lectures on, as I said in the beginning in the introduction, some of these lectures are going to be very basic building blocks, and others are going to be discussion type topics and think type lectures about culture and so forth. Today, the operating system is a little both, I think. Anytime you talk about software, something you can't really see or touch, you're going to have to talk a little bit abstract in the abstract. Software, or operating system software, is what talks to the machine, to the hardware. It stands as an interface between us, the human being, and the machine. And it tells the machine what to do based on our instructions. It gets the machine ready, able to accept our instructions, and then it prompts us to give instructions, and then it gives us the result of those instructions. We can talk about, in another lecture, we're going to talk about input and output and those kinds of things, but that all passes through this same interface of the operating system. So that's how we get between our analog world that we walk around in 3D and the digital world of the computer, which is just two states, on or off. Now it has two states now to trillions of locations. That's a terabyte and beyond. But it still only understands those two things, on and off, and it's quite remarkable that we can get it to do the things we do, given that how dumb it is. Remember when we talked about systems components, how inefficient the computer is in human terms. It does one thing at a time. It does them sequentially. It can't do leaps in logic like the human brain can. It can't make connections. But it does a pretty damn good job because it's so fast. So today we want to talk about what is that interface? What makes it work? What gets it started? And that would be the operating system. And the system software is the generic term. Comes in two types, operating systems and the utility programs. And we're all used to thinking of operating systems, most of us, as Windows. Well, that's one operating system. In fact, it's the largest, most used operating system in the world. Over 90% of the computers in the world run that operating system. It's an amazing statistic. But you need to keep in mind that a few years ago it was 96%. And even higher before that. So it's falling, and that's because of the mobile devices we all use now. Have different operating systems, most of them. We're going to go over these topics. Two types, I talked about that. The functions, what is it an operating system needs to do? The startup, mentioned that, and several standalone type operations and so forth. Let's get down here and talk about some of these things. The operating system itself, like I said, is the interface between analog, which is a continual state reality we live in, communicated by waves of sound or light, or we touch things. Those are all things we can do to get input. And we can get output by the same process. We can touch things and give them a sense, and then we can speak. My voice creates waves which go to you, and if you think about it, I'm creating those waves in a certain pattern based on what I have my vocal cords do. It's kind of unconscious to us, but we had to learn this, didn't we? We weren't born speaking. We were born making sounds. We had to learn that, so we had to learn patterns like everything else. And I speak English, and we have decided on certain patterns have certain meanings. And a wave goes from my mouth to our microphone and so forth, but if you were in the room, to your ear, and then your brain. And the message I'm sending is not sometimes is not the message your brain receives. Very difficult process when you really break it down. To get that into the computer, we have to go through an interface, which we talked about in input, which is converting it from analog to digital. The operating system is on the back end of that process of converting. So all it receives, in a sense, is digital signals from the conversion process, the input process. Well, in the other lecture, we'll talk in more detail about that. So the operating system controls the hardware, and then there's other programs called utility programs, which maintain the operating system and keep everything running properly. It's a way for the manufacturer of the operating system, in essence, to make sure things are running well, so you're happy with their operating system. One way to think about it. Here are some of the instructions. And every operating system, the Mac has one. There's the Android operating system that you've heard of for phones and mobile devices. There's iOS, the Apple operating system on the phone and the computers. So there's different operating systems, and they all have a different set of machine instructions. They're all different. Functions have to be the same. The functions, as we discussed earlier, were set down by guys like Turing in the early 1900s and von Neumann. So the processes, the functions pretty much are the same, but here they are on this page. And you can go through them. I will go through them as I lecture here. I'm not going to list them all here, but you can see what they are. And here's a list of all the things. So anything coming into the computer or going out of the computer has to talk to the operating system in one way or another. The operating system is also talking directly to the system components we talked about last time. So starting the system, how does that happen? You'd think this would be pretty obvious. Well, if you really think about it, the computer I showed you earlier didn't have any power in it, so it obviously couldn't do anything. But when you turn on a computer, when you plug it in, when the power starts, what do you think has to happen? Something has to get started, and it's, truth be known, it's not the operating system that starts the computer running. There is a startup procedure that's kind of burned into the computer in read-only or ROM memory. And that is installed at the factory and usually is never changed. And that has what's called the BIOS, which we'll talk about in a second. Basic Input-Output Service. So a cold boot is when you turn that power on. And when power hits it, the computer senses that and fires up the machine instructions stored in the BIOS. A warm boot is when you just tell it to reboot, Control-Alt-Delete on the Windows systems, and you're telling it, I need a new start, a fresh start. We usually do that because something isn't working properly. I call it the nuclear alternative. We're swiping the board clean and starting over. Both starts are like that. The cold boot's more nuclear, I suppose. A warm boot, you could say, is a tactical nuclear start. And I say that because if you remember when we talked about it, if we keep the power on, which is a warm boot, what stays? What is volatile, that if we do a cold boot, goes away, it stays when we do a warm boot, and that would be RAM, of course, and all the registers in the CPU and so forth. So warm boot doesn't really reset all of RAM. It does reload a new copy of the operating system, and cold boot does. So sometimes you may have some support person tell you to turn your computer off and restart it that way, and that's because they just want to be sure everything's out of RAM. There might be something in there that shouldn't be there. Okay, and here's the steps a PC goes through. Power supply, step one. Processor, the chip, finds ROM, loads the BIOS, basic input, output service or software. Which is what gets the computer started. It does a post. It's called, I'm sorry, I skipped this one over here. The post, power on self-test, that's what post is. Checks all the components on the system. It sends signals to every avenue it can, finds out what hardware is there. Why does it do that? Well, it needs to know what's talking to it. It needs to know what channels it needs to pay attention to. And it also has certain, if it does find things, it has to know, it has to load drivers. We'll talk about that in a little bit. And then the results are compared to something called the CMOS chip, which maintains the profile of your computer. In other words, what was connected to it last time I checked. And it will then know the differences and move on. Next, the BIOS say, I need an operating system, because the BIOS are not the operating system. So that's when it starts searching. And you can set this up in the setup procedures on where you want it to boot from. The sensible thing to do is tell it to look at the hard drive first and then look at a DVD drive. But you can also tell it to look on a USB port, which is what a lot of secure locations are doing now. And you have to carry a thumb drive with you that has the software on it. That way you have a protection, you know what you're loading. But most of us don't do that. There's a track on our hard disk, and the BIOS find your operating system there. And the system files, system software, are loaded where? We've talked about it. Only one place it can go, and it has to go, is RAM, random access memory, RAM, the volatile memory. And it's loaded at the bottom of RAM, but the whole operating system is not loaded. Probably 80, it's the 80-20 rule, probably 80% or maybe even more of what we do with the operating system is kept in about 10% or 30% of the operating system software. Remember, we talked about everything with computer design is about trade-offs between speed and storage and efficiency. We don't want to use up RAM, and we'll talk about why that is in a little bit. We all know that your RAM is a limiting resource. So the operating system actually only loads what's come to be known as the kernel, which is the basic operating system you need to do 80% or 90% of what you're going to do on the computer. That's, again, a resource decision. It doesn't take much RAM. If you tell the operating system you need to do something outside that 80-90%, it will have to go back to the disk and find that part of the operating system and load it into RAM. Remember, when you run a program, you've got to go find a copy of these instructions we call a program, move them to RAM, and start executing them. The operating system is no different. It's a program written by human beings, a committee, a group, a project of human beings. Operating systems are very complicated, but they're written, code. Somebody wrote your operating system. And of course, now the operating system goes from there. After the kernel's loaded, it knows what it should do, which is display something on the monitor and wait for you, which means it set up a prompt for you. Now, it's not an obvious prompt for Windows, as this system seems like a Windows system, but it's waiting for you to do something. That's what the startup functions do. So boot drive. We talked about booting. That's the same thing as starting. And it's the drive from which your software is loaded. And the reason I mentioned that you should have it set up to boot from the hard drive and then somewhere else is if you lose your hard drive, you might want to, well, you will want to be able to boot from somewhere else so that you can get the system running, and then you can take a look at the damage of your hard disk. Sometimes hard disks fail. So a boot disk is where you boot from. A recovery system disk, you can create that in Windows with the utility programs, and it will burn what it needs to restart your computer onto a thumb drive, onto a DVD, or whatever you want to burn it onto. And now you can recover your system. What that means is if your hard disk fails, where your operating system usually loads from, you have the option of booting from somewhere else. Very important thing to think about. All right. Shutting down the system. Well, remember when you're working, we talked about this, most of what you're doing, or everything, I'm sorry, is in RAM. And if you just turn off the power, the last changes you made won't be saved, probably won't be saved. So you should shut down the computer as a normal process, not just power it off. Most of us don't do that all the time because the software protects us from ourselves by saving copies. But generally, that's the best thing to do if you can. And there's other options here. sleep, turns off unneeded function, and then it puts the computer in a low power state. And you do that to save your battery. You have different profiles on your computer. One of the utilities your operating system probably has, which you can set up and say go to sleep after 5-10 minutes. And when you're on power from the wall, never go to sleep. When you're on a battery, go to sleep in 5 minutes if I don't do anything. And that's just keep your battery power, keep your battery charged. It's just to save power. Hibernate actually writes RAM to disk, saves, that's what save means. Writes things to disk from RAM, and then takes power from the computer. And it actually can start up without doing a boot when you hibernate. Hibernate means you can turn the power back on, and it should start up where you left off. The user interface, or we're used to this one down here, the GUI, graphical user interface. That's what Windows is. The Mac has a graphical user interface. When I started on computers in the Stone Ages, there wasn't any such thing, actually, really, as an operating system. What happened is you'd turn it on and it came up in a software package known as BASIC. And that's actually an acronym which I can't remember, which was a language developed by Dartmouth. It's a very inefficient language, but it would come up and you had to type in basic commands to do anything on the computer. Anything. Read a file, write a file, display something on the monitor, print. You had to write a program to do the thing. So in a sense, you were writing your own operating system. In fact, DOS, which was the first major operating system, disk operating system, that was developed by Bill Gates and his buddies when they lived here in New Mexico, was written in BASIC. So essentially what happened is it would come up in BASIC, and then they would type in run this DOS program, and it would start running. And they kept expanding it. The legend is they wrote it so they wouldn't have to load everything for their Dungeons and Dragons program that they always played. I don't know how true that is, but that's one of the legends. So DOS was one of the biggest early operating systems. There was many others before then, but none of them captured the market like DOS did, and we'll explain why that is. In any case, the user interface is the operating system allowing you to do something. So essentially, it's the window into the operating system. Think of it in those terms. What we used to have with DOS was this, a command line interface. That meant that there was no prompting. There was actually not even a mouse, if you can imagine that. I was talking to somebody the other day and explaining that when a mouse first came out, I hated it. I didn't know how to use it. I couldn't use it. I didn't have that skill. Sounds odd to say that since most of you grew up with mouses, Mies, whatever they're called. I didn't know how to use it. I taught myself to use a mouse by playing solitaire when Windows came out. But in any case, we had a command line, which means you had to know the commands, know the format of the commands, type them at the prompt. This is the prompt on this system. This is probably a Unix system, I'm guessing. Unix is an operating system we'll talk about in a little bit. And you had to type the commands. Know them, know the names of the files you're looking for, know the names of you had to know everything for these commands to work. And you might think to yourself how awful that was. Well, in truth, when Windows became a reality, I hated it. It seemed slow. With the line system, I could string a bunch of commands together by separating them with semicolons and operate 20 commands at once and then press enter and it would just do them all. When I got to Windows, I had to click, wait for it, click, wait for it, click, wait for it. You get the idea. I hated it. Of course, that's just what you're familiar with, right? The devil you're familiar with. And now, of course, I wouldn't want to go back to this, but there was an advantage to it. It's probably hard for you to understand. And some systems still use this command line interface for the operator of the system. When you have a mainframe, with 1,000 different applications running and 10,000 users and so forth, you have somebody on a console that may be using this. They probably have an interface, but it could be a command line at some level. Just be glad you don't have to do that. You all have GUIs, graphical user interfaces. Different levels of operating systems. And by the way, I forgot to mention, I may just call operating systems an OS or OS. That stands for operating system if I use that term. There's two, let's break these down. The first box says single user and multiple user. Well, your PC at home, PC is personal computer, if you didn't know, is single user usually. That means there's one person talking to the computer, and that's it. Well, of course, when I first started with computers, we didn't have anybody logged in but an operator. And then as we moved along, we started to get terminals hooked to the computer. That meant we had a monitor, called CRT, usually with green letters on it, and that's all, not colored, green, or gray, or orange. And that monitor and a keyboard talked to the mainframe. There was no mouse. You just sat there at the command line and did things, and things happened on the mainframe. And then the results came back to your computer. That mainframe had many users. Computers were so expensive, and the resources had to be shared amongst everybody. So the actual thing I had on my desk was called a dumb terminal. D-U-M-B, I mean that, dumb, because they had no software on them. They just had certain functionality that would send certain communication protocols to the mainframe. And then I would get the results on my monitor. That would be a multi-user system. The mainframe would be talking to all kinds of people. Everything we talk about in terms of functionality and how operating systems process works the same on single and multi-users. It's just the difference is there's a different area of memory for each user. Okay? Other than that, the concepts are exactly the same. Single tasking, multitasking. I think you can think of your laptop, your desktop as single tasking. It does one thing at a time. And then it moves on to the next thing. Makes it, as I said earlier, very inefficient, but the speed makes up for it. Multitasking might be many computers now have hundreds of processors running at one time. And then there's master processors which bring it all back together. Another concept is foreground and background. Right now, the foreground program on this computer I'm running, of course, is PowerPoint. There's also another foreground program running, which is Adobe Connect, or at least the web interface to it. And that's sending you the signal of my desktop and my video and audio. So those are foreground. In the background might be, I have the login screen for Adobe Connect in the background. I might have a bunch of programs in the system tray. This thing at the bottom. Those are background. That means they're not really running right now. They're just, but as soon as I click on them, if I were to do this, go to another process, like the desktop, well, that would cause that process, which is displaying the desktop, to move into the foreground. And that's what happens. So foreground means that's what the processor is working on, has priority, let's put it that way. Background means it's low on resources. It's just sitting there waiting for something to happen. There are certain processes that the operating system will get what we call interrupts, and they preempt whatever's going on, and they get priority. That might be if you plug in a USB drive, it'll pop up. Should pop up, most of the time it does. Those kinds of things, or a printer, somebody plugs in a printer or something, another page has to be sent to the printer. The operating system gets a signal that interrupts the normal processing. And those are preemptive multitasking things, but they still, on your computer, are happening in single order. And multiprocessing means you have more than one processor doing things at once. Okay. There we go. So as you can see here, the background programs are the things that are down here that you're not doing anything with, okay? And it's also, there's a lot of tasks the operating system is doing, and they're running in the background all the time. You don't even know they're running. You don't even care. Let me just show you real quick. If I go to Alt-Control-Delete here, I hope, maybe you can't even see that. Let's just not do that. Never mind. But if you go to Alt-Control-Delete and go to the Task Manager, you can see all the background processes that are running there. And you should take a look at that at some time. You won't hurt anything. Resources are the most important thing for computers because You always run within limitations. You only have so much memory. The chip only runs so fast. We can only move data at these speeds. So we have to make things run very efficiently. You already know what RAM is. We've talked about that. We'll talk more about that when we do input, output. Memory management is how do we manage that memory? Once upon a time, when you filled up RAM, the system would tell you, I'm sorry, I can't do that. You'll have to stop another program to do that. Because RAM was full. Well, operating systems are smarter than that now, and it will take a hunk of RAM, memory, if you will, and write it onto the hard disk. So it takes an image of RAM, as it stands right now, writes it on the hard disk, and that's called virtual memory. Okay? So you can see here, this is RAM. That's what it looks like. And it takes the most recently used, least recently used, and moves it from RAM, takes a copy of a part of RAM, and transfers the data and writes it on disks. Then it takes whatever you wanted to load, but RAM, there wasn't enough information, room, and loads it into RAM. This is called a swap, memory swap. And if you're running too many processes on your computer and you're filling up RAM, this is happening constantly. And let's be clear about this. What that means, RAM runs at close to the speed of light. If you run it using too much RAM, you have to swap it out and write it on the hard disk. Hard disk is a physical device. Runs very slow compared to RAM. So if we have to do this, move something from RAM, write it, read something from the disk, move it to RAM, process a little bit, and then swap that to disk, and then bring something else back in a continual process, that slows down your computer tremendously. So if you're having trouble, and you can tell this if you have a light on your hard disk when you're just sitting there and it's blinking on and off a lot, probably means you're swapping. So why do we have to do this? Let me go over here and draw a few diagrams. We've got the hard disk here. And then we have the operating system. And over here we have RAM. Okay. So operating system, let's just draw this as well. We have a monitor, which is waiting for your input. We have a mouse, and we have a keyboard. Okay. You click on something. When you turn the system on, let's start there. We know that the operating system, a copy of it, resides out here. Well, the BIOS, basic input-output service, finds that operating system. It doesn't have to be on the hard disk, but it usually is, and moves it into RAM. Let me start it. There we go. So the OS, and it moves it into RAM and puts it at the very bottom. That's the first thing that gets put in there. And we'll call, and that is, darn it, these buttons are not cooperating. This is called the kernel. It is the OS system, what you need to do the basic functions, 80% or so. And that's loaded in there, and then it starts operating, which means it prompts, and it sits here and waits with the user interface. Okay, and then let's say you run Internet Explorer. Same thing happens. There's a copy of IE here. The operating system puts it into RAM right above the kernel if that's the first thing you run. And there's also some communication software besides Explorer that connect to your internet service provider or your network or whatever it is. So there's communications, and that has to be loaded. Everything comes from the disk into RAM. So now you've got your network running here. You're communicating. And you're browsing the internet. And remember, there's a lot of things that run here. There's something called Flash and other things that run, plugins they're called. Those have to be loaded from here into some part of RAM. And then let's say you want to run iTunes or Spotify. And that's, of course, there's a copy of that software over here. I know you can't read this stuff, so you got to follow along here. So Spotify gets moved and put here. And then you say, I want to run Word. Well, there's a copy of Word over here somewhere that gets loaded. So you get the idea. The operating system is finding things on the disk as you tell it to and moving them or loading them into RAM. Okay? And then your document that you're working on in Word has to have some space for what you're typing to be stored, which it's not much, but it has to be there. So the operating system is doing all that, and all of a sudden you say to yourself, you know what, I need to run PowerPoint. Well, if you can see here, your RAM is full. There's no more room. Okay? I messed up this diagram. This should be RAM. Sorry about that. Don't worry about this for now. So the operating system is what stands between these two. It does all this functionality like I mentioned. So your RAM is full. All right? So the operating system, it used to be, as I said, if you tried to run PowerPoint, let's say. So PowerPoint is over here on the disk. And you click on the icon on the desktop, which says PowerPoint, which is really a hidden command to the operating system. And it gives the location on the disk where the program or instructions that some human being wrote reside. And it says, go to that location, get that set of instructions, and move them into RAM and start executing them. That's what happens when you click on PowerPoint. But the RAM's full. What do we do? Well, it takes the least recently used, which probably is Internet Explorer, let's say, because Spotify continues to play and communications continues to communicate. And you just did something in Word. So let's just take that. It does what we call a swap, which means it takes a snapshot, if you will, a copy. So that's your IE. So that's your version of IE, not this one. This one's the original. You don't change that one. It never gets changed. That's the program. So it takes that snapshot of RAM and moves it out and writes a copy onto the disk. This no longer has Internet Explorer in it. Now to the operating system, this is memory management we're talking about. That space or that area of RAM is now useful. It's free. Because we created what we called a virtual memory by swapping RAM to hard disk. Remember, the hard disk is very slow. All those zeros and ones get written over here, written on the hard disk in temporary storage, it's called, but it's still on the hard disk. And then PowerPoint gets loaded into that location and starts executing. Okay? And so you're running in PowerPoint, Spotify, you're still communicating with the internet because you don't want that to go away. You're doing a little Word. And then you decide, oh, I need to look something up on the internet. What do I do? Well, there's no RAM available. So the operating system has to do another swap. And let's assume you haven't used Word in a while. So now it'll take the Word, find some space here, and put Word, a copy of Word, or swap Word, and remove it and tell RAM this is no longer being used in your document. Okay? And then it takes Internet Explorer, a copy of it, writes it back into here, and I did that incorrectly because that's actually this copy of Internet Explorer, the swapped copy, and swaps it back in. And you execute from where you left off before. Your web page is still there, your connections to the web pages, everything is like you left it, like nothing happened. This is all happening kind of in the background. And when you do it, it's just clicking on an icon on the bottom in the desktop tray or switching windows with Alt-Tab or something. But this is what's going on in the background. The operating system is managing memory by swapping the RAM or writing it into what's called virtual memory on the hard disk. If you have to do that, it slows down your system because hard disk is slower than RAM. and all this processing. If you had enough RAM, you wouldn't have to do any of this. So this is why more RAM makes systems run faster. I hope that makes sense to you. If not, we can discuss it in the forum. So the next thing we need to think about in the operating system, so that's managing memory, it's all about resources, is the order in which tasks are processed. Okay? So it has to make a decision. As I said, your desktop and most computers do things in a sequential order. What's next? Okay, what's next? Okay. Well, it has to decide what to run next. And there's a priority set to things. And usually the priority is what is run least recently. So the oldest thing, the thing that hasn't run in a while, usually gets put at the top of the queue, let's call it. And so it queues it up, and that runs next. And the one thing that just finished was on the top of the queue, moves to the bottom of the queue. So if I go over here, let me draw this up real quick. You can think about it as a, what is it? Yes. LIFO, last in, first out queue. Whatever's at the top of this queue gets run next. So in our example a minute ago, you started PowerPoint, and so that's running now. So something, and remember this is 1,000, 10,000 instructions of PowerPoint, whatever it is you're trying to do gets run. But remember Spotify has to keep playing that music in the background. So it's queued up next. And then maybe Internet Explorer, because you're doing things on the internet sometimes. So whatever happens has to happen next. So PowerPoint gets the processing, or it gets the chip, the processor, for its allotted time, and it runs some instructions for PowerPoint. Then PowerPoint goes down here. Spotify moves up here. It plays some music. Spotify then goes down here. PowerPoint moves here. Then Internet Explorer gets into the processor and runs a little bit there. And then when it's done, it goes down here and everything gets pushed up. And that's a continual process. There's also background processes like, well, check the USB port. Anything happened there? Okay, nothing happened there. Check the printer. Does it need more? All these things are going on. The communication software, what about that? Is that still connected? Or you need to let them know it's not working. All those things are going on, and they get put into a queue. Now, the background system processes, if they fire up, if something makes them happen, they go to the top of the queue. They're the priority ones we talked about, the interrupts. That means they'll go at the top of the queue. So this is how it works. Sets a priority. Everything gets the same priority except the system background things. They get a higher priority because it's crucial. So memory management, for instance, runs up here somewhere all the time. It does go in and out. So another way to look at this, and the way we used to look at it on the mainframe, was you'd have a queue. And if this is your CPU, the amount of time something gets on this circle was how much processing time they got. And the size of their circle would say how much priority they had. So the shortest circle would be the system. The next one might be the payroll system on our old systems, and so forth. And this outer one would probably be the users on our mainframe. On your system, there's only one user, but all these things probably get close to the same priority except the system. So after it's in the queue, it goes down in the loop. You're the biggest loop. The system have the shortest, so they get to go back and get more of the resources. All right, so that's the queue, and that's how the system decides. Okay, you got your time. Go back in the queue, and you move around this circle. Time you get back at the top, you get another slice of the CPU. You might be saying to yourself, well, that doesn't happen. I don't see that. Well, it's happening in the background. If you're running all kinds of things, it is happening. Everything gets its slice of the CPU and moves on. It's so fast, you don't even notice it. Spotify never pauses and waits for the CPU. It continues to run, or iTunes. Spotify is a cloud player where you can pay a monthly fee and watch music. I should have explained that. Think of it as iTunes, if you will. So it's processing things, and it gets its time slice. And this happens constantly. And the CPU is running it. So the faster your CPU runs, the more it can do during this time slice. The more instructions it can execute. So you can give the same amount of time with the CPU, but more can get done if your chip is faster. That's why faster chips are better. Okay? So this is how, the processing, how it happens, and that's how the processor decides what is happening and what happens next. And this is the diagram they use here. And they're just showing you, these are the different things. Print spooling is one thing that happens. Document being printed. And those are the processes. There's many running, and the CPU only does one thing at a time, so it has to set a priority and figure out which to run next. And it's kind of complicated. If you want to, we can discuss it in the forum, put some questions in there, and we'll discuss it, okay? So, but that's the main function of the operating system, managing resources, one of those is the chip, memory management, that's another resource, memory, and it's taking care of all that in the background. You as a human being are so slow compared to the computer. It all seems seamless to you. Music keeps playing, your PowerPoint, whatever you look at functions. Okay? Especially if you have more RAM. If you're doing less swapping, it's even better. Okay. So let's talk a little bit about hardware, other hardware in the operating system. So you buy a printer with some manufacturer, let's say it's HP. And over here we have an OS communicating with, let's say, Dell hardware. Well, Dell hardware has a certain machine instruction set. Apple hardware has a different machine instruction set. Every hardware manufacturer has a different instruction set. And the OS has to be able to talk that language, if you will. So you buy a printer, and once upon a time, the printer had to come with a disk. Many of them still do, but they're usually not necessary. And when you plug in this printer into your hardware, you USB port normally these days, the operating system has to sense it. So somewhere in this printer, there's some kind of code that says, I'm an HP 123 printer. And the operating system says, oh, I know what that is. Or, well, I know you're a printer. I don't know what HP 123, whatever. It can get out of that code it tries to get. So it says to itself, and this is the first time you printed it, plugged it in, sorry, says to itself, I need to talk to this piece of hardware. Well, how do I do that? The people that write the operating system cannot write understanding of every hardware in the world into the operating system. It'd be huge. And what would happen if you came up with a new piece of equipment and it wasn't put in the operating system? And this used to happen. You couldn't buy that system because your operating system wouldn't work with it. That hardware only worked with other operating systems. So you had to get them, make sure they were compatible. So we came up with this concept called a driver. And that's a little program that runs within the operating system that talks to your hardware. So that driver understands the commands and the messages coming from that printer and knows how to send those same messages back. Okay? So that's what a driver does. It's a tiny program, small, but it's sort of like a translator between HP 123 and the operating system. Because the operating system only has one set of instructions to talk to the computer itself. It doesn't change that. It just has to have a driver to translate between different printers. If you then went out and bought a Dell printer, an Epson, each of those has a different language. The driver has to translate it so the operating system knows how to do that. Now, like I said, it used to be that that was a big deal. Operating systems didn't handle that very well, and you had to be very careful. Some printers, some hardware only worked with some operating systems. That's less of a problem these days. Although there are some hardware that only run on Macs or only run on PCs, but much of it will run on both with the proper drivers. So that's what a driver does. If the operating system is smart, It has, not in the kernel, but on the hard disk, has some generic or basic drivers, printer drivers, camera drivers that it may try to use. If those work for your printer, great. Occasionally those won't work, or it doesn't understand, but it knows it's a printer, so it'll tell you, I can't find a proper driver. Do you want me to look on the internet? And then it will go look for you, and based on the code that it has here, HP123, it'll try to find that on its own if you ask it to. If you can't find that driver and download it, you can do that. You can download it and then point the operating system to that driver. And from that point on, the operating system knows, when I get this code, use this driver. And it works. So once you get it running, everything is fine. The operating system then can talk that language back and forth, and it always knows how to talk to the hardware itself, okay, the components of the system. That's kind of that's what a driver does. And the concept now is plug and play. You plug in a printer and it usually works. And I would say that's 85, 88% of the time that's true. You don't have to do anything with it. Sometimes the driver you're using isn't 100%, doesn't give you all the functionality you need, so you may have to go to their website. I've had drivers kind of work, but not, so I go back to the manufacturer website and download a newer one, and it works better. Windows will sometimes ask you if you want to update the driver, and you can do that as well. But plug and play essentially is you should be able to plug in any device. Your operating system's smart enough to make it work. It's a great breakthrough, which most of us take for granted these days. It's about the driver. That's what plug and play is. Communications, okay. Connections, that's one thing the operation OS does for you. You can also get third-party software that does that. There is a performance monitor. If you do Control-Alt-Delete, go to the task manager. Inside there, there's a tab for performance. CPU is one, memory, disk, network. And you can see if your system's running slow, it would be interesting to look at the memory. Maybe I don't have enough RAM. Maybe I need to add RAM. And that will tell you. You can see here, this CPU is running, what, about 60%? Generally, and that's a lot, actually. So this person is running a lot on their CPU. Now, while you're on this screen, this performance monitor, the other stuff's still running, whatever it is that's causing this CPU to run. And remember, if you're communicating to the network and the internet, that runs constantly. That's taking a little bit of your CPU. Down here, you've got disk usage, as you can see. And this is 60 seconds of time, 100 kilobits, or we talked about that. A kilobit is 1,000 bits, or 1,024 is really what it is. And it's telling you these are usually writes and reads, access to the disk. Not much going on there, which is a good thing. If you're swapping, moving memory from RAM into disk, this will go all over the place. So you can take a look at that and see. And there's also the memory tab, which will also help you with that kind of thing, diagnosing that problem. You should look at that. It's not hard. Control-Alt-Delete, task monitor, and then you can go in there and look at that. So there's other things the operating system does. And that's what this slide's about, managing files. So what this is, these are the things that allow you to get things to happen and tell the operating system to do something other than operate the computer, essentially. If you think about it, how the files are stored on your hard disk is a decision made by the operating system. Now, you can tell it certain parameters on how to set it up, but it only knows certain ways. And I'm not going to go into what those options are. But once you set it up, it has to know what that is, that setup is, and know how your files are stored and manage the storage itself. The operating system does that. And once you put files out there, what if you forget where they are? Well, DOS, it was very difficult. It was hard to search. Windows allows you to type in something and search for it, which is a good thing. And then, of course, looking at images, security, installing and uninstalling programs, cleaning up disks. There's all kinds of temporary data and garbage, I call it, that gets put out there, and it just never goes away unless you tell the operating system, clean up all that stuff you're not using and give it back to me. And you can do that too. defragmenting and backup and recovery. So let's take a look at these. This is the automatic update function. All operating systems have this because it's a great help to have this happen automatically. You used to have to do it yourself manually. This is kind of nice. You can set this up to run once a week if you want, which is what I do on the computers here. You know, we have too many of them to do them manually. I prefer doing it manually so I know what happened, but it's too many. So on Saturday night, I think 1 a.m. or something, maybe it's 3 a.m. Saturday night, I have the weekly update set to run. And what that does is go into the vendor of the operating system. In this case, Windows, of course, is Microsoft. And it's built into the operating system. And it goes to their website and compares what you have, the operating system on your computer, to what they have. And it says, oh, I have a new version of that particular part of the operating system. Very complicated because there's many parts to the operating system. And it updates it. Gets a new copy, installs it on your computer. Sometimes you have to reboot, sometimes you don't. But it's very important. You can also in here set up to update Microsoft products like Office. You can put a setting in here to update those too. Every operating system has this function. Windows updates its operating system often, mostly for security reasons. You have a situation in the world where we have, and we'll talk more about this later, but briefly, we have a situation where we have these idiots who think it's kind of funny to write what we call malware, badware, not software, badware, malware, malware, to attack systems. And what they do is take a look at the operating system that you have, and they find what they call ways to get in, to exploit. They call them exploits. So holes, if you will, in the armor of your security system, and they'll write programs to use these holes to put malware on your computer, and sometimes they damage you, sometimes they just sell Viagra, sometimes they just keep track of what you do and see if they can get your social security, all kinds of malware, which we'll talk about in another lecture. But the Windows, Microsoft, constantly testing and running things and trying to find all these so-called exploits, and they try to plug them up. And that's normally what the updates are, to the operating system anyways. They're plugging up those holes. So Windows has updates constantly, usually security updates, not always. And they're plugging those holes from the malware. And people often point out that own Macs and Apples that, well, Apple almost never does an update. And that's true. I have one on my desk, and I mostly use Windows, but I have a Mac system too, so we can test it with our software, with our systems. And rarely is there a system update to the Mac software. And people point that out as showing how good the software is, but the truth really is that there's not a whole lot of malware out there for Macintosh operating systems. And that is because if you're going to take the effort to write programs, let's go after 90% of the systems in the world and really do a job. Why would I want 6 or 7% of the systems? It's a lot of work for that. So generally, people don't target Macs. But the operating system does its own updating, and other updates you can ask it to do as well. Programs, application programs, which we'll talk about in another lecture, you may have to update those manually if they're not Microsoft. Although many of them now embed their updates into this process too. The Mac has an update process I run once a week just in case. Every operating system has an update process. Some operating systems work as servers. What does that mean? Well, that means they can do more than your standalone Windows operating system. That means they run on a machine. Generally, there's nobody on that machine, but there's people logging into that machine, and the machine is managing resources for all of these people. Often it's just a network it's managing. It's taking care of moving the signal along on the network, if you will. Sometimes it's software. Companies are starting to go to this idea of sharing software amongst people. It's been around for a long time. We're starting to go back to it. Or maybe they just have storage that everybody shares. Whatever it is, the server handles all this. Now, every website you go to has a server. That software runs differently than the software in your system because yours is not server software. Server software allows that hardware to do more with more connections from outside the computer itself. That's basically the difference. Mostly about users, resources. Sometimes people are not allowed to install software in their computers. Might be where you work, and they can do that through the network, perhaps. Another function of an operating system is user name, ID, password. Windows has this. I'm guessing most of you don't use it because you're the only user on it. But we have at least 2 users on our systems because we have one for the professors, which doesn't allow them any capabilities other than to run PowerPoints, those kinds of things. They can't change anything because it's not that we don't trust the professors, it's just that sometimes the rooms are empty and other people can come in and load stuff on it. We want to minimize changes to our system, random changes. So we have another one, an administrative user, different user ID, different password, and we can log in with that user and we can do updates and things with that user. So here you can see there's 1, 2, 3, 4 people using this computer, and each of them has their own user. And what that allows is the way they set up Windows, the files they own come up. So it makes it more convenient for people. And if you want to, you can set different levels too for the functionality these people do. That's something you can do. Categories of operating systems. They're standalone. They only do one thing at a time. You know, that's all they do is what they're doing. And I mentioned disk operating system. It's DOS. You might be interested in the urban legend about that. There was an operating system called CP/M. The early part of my career, we used it at the consulting firm I was at. And it's a very good operating system. It could do things. It was very efficient. It could allow you to share word processing software amongst everybody. And there was a lot of software written for it. It was starting to grow at a tremendous rate. And it was the software to have, CP/M. I don't remember what the CP/M stands for. But it managed things for you. And it actually was more of a server type, but each of the people on the server also had to use it. So CP/M would run on all the desktops, but then one would be the master, essentially. And everything was managed. And it was just tremendous. And it was constantly being updated and made better. Well, this was in the days of Silicon Valley exploding, and I don't know who the individual is. The guy that developed CP/M was doing really well, very wealthy, and he was having fun. He was changing his code. People were using it. He was really well known. He was on the top of the heap. A company called IBM was getting into computers then, personal computers. They'd been in mainframes and so forth for a long time. In fact, you may not know, but IBM is the company that started the whole PC business. Your desktop and laptops were, the idea, the marketing of it came from IBM. But anyhow, IBM was thinking, we need an operating system if we're going to start selling these personal computers or PCs. So they compiled a list, did research, and see what everybody was using, and CP/M was at the top. It was the best. So they wanted to use that and all their millions of computers they were going to manufacture because it was the best. Story goes, they made an appointment to see this individual, flew out to Silicon Valley, and IBM in those days only wore white shirts, black ties, black suits, black shoes, black socks. And they came into this office with their briefcases and their black suits and black ties and white shirts. And the woman sitting as the receptionist, who was no doubt, this was in Silicon Valley, probably wasn't dressed real formally, kind of had to tell him that the owner was out hang gliding. IBM said, well, let's go see who's next on our list. And they crossed CP/M off the list. And they went to see another guy by the name of Bill Gates who had this thing called DOS. That's the legend. I don't know how true it is. But anyhow, so DOS became a dominant operating system just because IBM adapted it and put it on every system they sold. Amazing, amazing story. That part of it is true. And that's kind of what started Bill Gates on his career as a genius. If IBM hadn't bought that software, we probably wouldn't know who Bill Gates is today. But DOS was the first one, and then we had, and it was written, as I said, in BASIC computer language, and we'll talk about that when we talk about computer languages. And then eventually he wrote a user interface software called Windows. Remember, DOS was a command line interface, CLI. Windows had a GUI, graphical user interface. And they wrote that, and the early versions of Windows actually were written in BASIC. For years it was written in BASIC, and I think it was with Windows 3.0, if I'm not mistaken. They changed it to a language called C, and Windows is still written in C. I think that's correct. C is a very efficient language, and much better than BASIC. But in any case, it's a program written by people, and they've improved it. We're most of us now running Windows 7. If you're in, and of course you're probably running an older version at home, that's fine. But just so you're aware, Microsoft no longer supports Windows XP, which means it will no longer be plugging security holes in Windows XP, and you're not going to get updates to it. That's what that means. But it'll still operate your system, of course. It's not going to stop operating and doing what you need it to do. It's just that it won't advance from this point forward. At some point, you'll have to update it just because it'll stop being, it won't be very efficient. And of course, this graph doesn't have it, but they're now talking about Windows 8, which is the latest version of Windows, which is a dream Windows has always had, which is develop an operating system that can be run on any platform, any device, small, big, and that's what Windows 8 was intended to be. It also takes advantage of the touchscreen technology, so it can run on pads. And the concept has revolutionized things. Microsoft is very smart, and they've actually developed devices. I don't remember what they're called, touchpad maybe, I don't know. But they're devices that don't have keyboards, so they're kind of like a little more than an iPad, a little less than a laptop. And they can plug into a keyboard and act like a laptop, but they also can act like an iPad. And Windows 8 allows this to happen. It's a very good operating system. We're going to load, the new equipment we buy is going to have Windows 8. We'll see how it runs. You can tell Windows 8 to run like Windows 7, so it'll show you what you're used to, or it can do the new thing, which is about tiles and icons and all. There's no desktop as there is in Windows. It's just about what you've done most recently. The Mac OS, and let's take a look at this. Forgot I had some slides in here. I'm not going to go through all these different versions of Windows 7. The Mac operating system, this is a Snow Leopard. I think that was one of their operating systems. I think the latest version is actually called Mountain Lion, if I'm not mistaken. But there was one called Snow Leopard. And there's a version beyond, I think Mountain Lion's the latest, which supersedes Snow Leopard, if I'm not mistaken. But it has its own architecture and its own way of doing things. But it's essentially Windows for Microsoft, and I know, for Macintosh. I know Apple users will just cringe when they hear me say that, because most people believe Apple created all this interface, and it just isn't true. There was a place called the Xerox Innovation Center, I think it was, and they developed all the ideas of GUIs and mouse, clicks, icons, and they did it for free. This was in the golden age of big business in the States when they weren't controlled by the government, and they pretty much had monopolies, many of them. Xerox did have a monopoly in the copy business, but they used that money to develop technology which they would give freely. Those days are kind of over, but this facility they had was constantly trying to find ways to push barriers, and one of the visitors to that in the early days was a guy by the name of Steve Jobs. He came in and saw what they were doing and copied it for the Apple, and the interface of the Apple in the early days was much superior to the Windows environment, DOS, Microsoft environment. There's no question. For years, if you were doing in graphics, newspapers, publishing, advertising, you used a Mac because the DOS Windows stuff just didn't do that stuff very well. So there's always an advantage. I don't believe there is an advantage anymore. But pure Apple users will tell me I'm totally nuts. So, you know, that's an ongoing debate. It becomes a belief system. Some people say Apple is a cult. It isn't a company. But they make good products just like everybody else. They have negatives. They have positives. It's a matter of what you want to do with your system. And, of course, there is a way to run the Mac OS and at the same time run Windows on the Mac, and you can run both, so you can switch back and forth. So if you have Windows files and things, because remember I talked about this, the format of files is different on the different computers. So something to think about, but the Mac OS is X or 10 right now, or Mountain Lion, I believe, if you go to their website. Unix, developed years ago by Bell Labs, I believe. And remember, this is in the days when people shared things. Well, Bell Labs, at that time, this is before Microsoft, their operating systems, there wasn't any such thing, and so they had to actually write them, if you think about it. And they wrote one for their machines, and they called it Unix. Unix today runs on a heck of a lot of computers because it's what most web servers and internet servers use, is Unix. Unix is used for these things because it's much more efficient than anything anybody else has. It has a very, what we call, small footprint, which means it takes up very little RAM when it runs. The kernel is very small. And it is very efficient in terms of talking to the machine. It's better at it than most other software. One of the neat things and amazing things about Unix is that you can get what's called the source code. And when we talk about programming, you'll understand what that is. That's essentially the near human commands you enter, which are then run through a program and become machine instructions. So you can get the source code to Unix and change it. Can you imagine you get the source code for Windows means you can rewrite it to your own needs and make Windows do what you want it to do. And then you have to recompile it or turn it into machine instructions again. So essentially what you get is, in the early days especially, every company had their own version of Unix because they would get the original Bell version and they would modify it for their own needs. Pretty amazing stuff when you think about how we use Windows and the Mac operating system. We don't get to change that. We don't get to rewrite code. It's open source, it's called. So Unix, so it gives you enough rope to hang yourself, is what some people say. Others say we can change it to how we need it to run. So periodically, people that run Unix have to reload the kernel, just because it's, in some ways, it gets a little fishy in terms of managing memory. It gets lost at some point. So at least once a week, most people reboot their Unix server and reload the kernel. Now, because of all these changes, there are certain standards in Unix which people try to adhere to. And many companies use one of these standards and don't modify it anymore because it's harder to support things when they're all custom made. Linux was written by a guy, open source again, Unix type. There's debate about whether the guy used parts of Unix to start and then wrote Linux. And I'm sorry I can't remember the guy's name. I think he's Scandinavian that wrote Linux. And it's much smaller than Unix, and it's easier to use, modify, and so forth. A lot of people use Linux on their PC or desktop or systems because it's easier to run than Unix and has a better interface and so forth. Remember I said Unix can run on every platform from mainframe down to your PC. You can load Linux or Unix on your PC if you want to. And we have systems around campus, PCs, that run Unix or Linux, probably Linux. Okay, yeah, there it is, Bell Labs. Many have contributed over the years, that's what I was talking about. You can write code and then put it up and share it with other people. And it's interesting, the Apple OS is based on Unix. They started with Unix and built their own. AIX is IBM's version. HP had one called HPX. Solaris is a widely used version of Unix. Sun Microsystems uses it on their computers. And Linux, they say, is based on it. But because of a lawsuit, the guy that wrote Linux claims he didn't start with Unix, but I don't know whether that's ever been settled. All right. Of course, Windows, as I said, you can't change. But it's not based on Unix either. It was developed by Bill Gates and his buddies, as I said. These others started with Unix and built. Okay. And these are server operating systems. I'm not going to talk about this. Is the one we're using now for most of our servers. But these are used in the internet a lot. These are used in certain graphics systems and so forth. NetWare is used to run a lot of networks. That's what it's designed for. And Linux, as I said, are used by people around our campus, but scientists often, because they like the idea of being able to be closer to the code and change things. Didn't want to mention real quickly, oops, pressed the wrong button here, bear with me. Let me find out where I was here, sorry. There we go, let's just start here. We were talking about 2008. This idea here, virtualization, and I'm just going to talk about it for a second here. The idea of virtualization is Windows Server, for instance, 2008, allows you to emulate hardware in the software. So I could take my Adobe Connect server, which is running this class, and run it on another server. And on that server, I could also be running our server that now has a separate system running our serving you the video and the downloads and the portal and the website. And those can run kind of in a cloud, if you will. That cloud's on our server. That's called a virtualization. And the idea is you can emulate the hardware so the software doesn't need to change, but you're running everything in RAM, essentially. There is no real hard disk in that sense. You can write and read hard disks, but it's all running up in a RAM on another system. So you can take all your current servers, different hardwares, run them in a virtual environment, and have one server running all your, quote, servers. And the advantage of this is that you can take a backup of any of your servers. You just take a snapshot of that part of RAM, and you have a backup. It's kind of a neat idea, and it's growing. And if you think about, if you've heard about cloud computing, that's putting your stuff up there on the internet, essentially. And that's a form of virtualization, if you will. And you can eventually, you will be able to run everything from the cloud. You won't have to buy Word. You just pay a monthly fee, and you have access to programs and so forth. It'll make things much more flexible. Maybe if you don't need Word, you don't pay for it this month. Those kinds of things. And what that does is move the responsibility for updating and maintaining to someone else. You don't have to have all that stuff on your computer. That's the basic idea. And it's a growing technology, very important. And that's about all I want to say about that right now. Embedded operating systems. These are things that run on your portable devices, if you will. Phone 7, Palm, early mobile devices, Palm Pilots, they were called. The iPhone, iOS, you know this as. BlackBerry has its own operating system, and I had a BlackBerry phone until recently. And the operating system was okay. The phone itself was great. Did some great things. I wish I had the phone interface on my Samsung Galaxy. It was much better. But what I didn't have with BlackBerry, because it has a BlackBerry OS, are all the apps you get with this one, Google Android. So my Samsung phone uses the Android operating system. I now have access to, tens of thousands of apps, which I had maybe 600 for the BlackBerry. Most of them written by BlackBerry to try to save their business. So these operating systems are integrated very closely with the hardware, more so than the operating system on your computer. And the hardware will only run on that operating system. You know, generally speaking, you can do what's called a jailbreak, which is going in and modifying things. But most of us don't want to get into that. But they're intertwined. This hardware is designed to run on this embedded system, and they're hand in hand. So that's why they're so powerful, why they work so well and so efficiently, is because hardware, software designed from the ground up to work together. Those are embedded systems. Here's some pictures. This is a sewing machine. But of course, they now have software, especially embroidery sewing machines where you can do team logos and things. Anyhow, that has an embedded operating system. I don't know what it is. So as you know, your phones. Now, utility programs we talked about earlier, these are programs that come with the operating system which allow you to do things. So now we're going to move from the operating system per se, which all happens pretty much behind the scenes. You don't care that much about it as long as it runs. It understands what you tell it to do, what you want to do, and it talks to the hardware, manages your memory, manages your files, manages your chip, your CPU, communicates things across the bus. That part of the operating system was what we've just been talking about. Now we're going to talk about the things that run that allow you to use resources, if you will, or to just get more use out of it. One of those, of course, is a file manager. Every OS has its own way of managing files, so it better have its own file manager so you can get at your data. And we know about folders. Those are where you store things. Shortcuts, those are those icons on the desktop you click so it goes places. We all know, based on what we do, we know that when we need files, we go to something called Windows Explorer. That's where you can look at all your directories and folders and files. That's what this is. This picture is Windows Explorer, which is not the same thing as Internet Explorer. This is Windows Explorer. And you can search. And every time you see that yellow thing, it found you were searching for FLOW. That allows you to find files that you stored and you can't remember where the heck you stored them. Because there's 100, I have 2.8 million files on my laptop. So I need the search. And these are some other utility programs. Image Viewer. You can use the image viewer that comes with Windows, and it's fine. But most people get a third-party thing that allows you to edit the software even. Office gives you a better image viewer than Windows does. It allows you to crop and do some things. But Adobe, of course, has software that allows you to do some really interesting things with images. But anyhow, most operating systems come with something so you can at least see these things, but they're not very extensive or very functional. Uninstaller, well, you have to install programs. Like if you buy a game, you want to install it on your computer, or a design software, you're going to install it, which of course means you also have to uninstall. And when you install, there are actually files put in your system somewhere that tell Windows how to uninstall that software you just installed, because it's installing files all over the place. So there's actually instructions the manufacturer, the people that sell the software, put on your hard disk that tell Windows how to uninstall it, or the Mac OS, whatever it is, how to uninstall. So that has to be a function of the OS. Disk cleanup. Well, notice there is a thing you can run in Windows. If you go to My Computer, right-click on the disk you want to look at. I don't remember exactly how it comes up, but you can click on Disk Cleanup. And it's showing you here how much space is being used and stuff you're not using. It's just there. It's what I call garbage. It's waste. And it says a total of 60 megabytes, which these days isn't much. But especially the temporary internet files can get up into the gigabytes sometimes if you let it go forever. But what you can do is click on this button, and it'll give you back 60 meg to store data with. Once upon a time, 60 meg was a lot, but anyhow. You can see offline web files, game statistics, debug, dump. That's when something goes haywire. It keeps binary data for somebody to analyze. Anyhow, you can do that. Operating systems will come with that. Clean up the garbage. When we talk about input-output, that lecture, we'll talk more about this picture. But disks, hard disks, storage disks, store data in concentric circles. You can think about it in those terms. Tracks, they're called. And it doesn't store the file in one big go, and then the next file in another big go, because that's inefficient, really. It will start that way, but then maybe you'll store a file in here, and then another little one, and then another little one, and then you're going to delete this file. So now this space is free. And eventually your disk gets chopped up. And what Windows will do, you can see here, all the brown you see on here is one file. And Windows will store, wherever there's free space, it'll break up your file. Otherwise, it might tell you, sorry, I can't find enough contiguous space to store your file. So it'll break it up so it doesn't need one huge space. Now, when you retrieve the file to look at it, you don't know this is going on in the background. So what a defragger does then is put it all back together. You can see this file is fragmented, broken up. And after you run the defragging software, it puts the file in contiguous space. That's what the defragger does, puts everything back. Why is that important? Well, if your disk is fragmented too much, it can slow it down, because if you want to read this data, it's got to read here, 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 here. If it's in one space, it starts reading and just gets it all in one go. If it has to do this, it has to read in many places, which slows it down. So it's a way to speed up your system. If it's defragmented too much, defrag it. And Windows will tell you, there's a test, analyze, tell you if you need to do it or not. We'll talk more about that when we talk about storage. Backup. You should all do that. Windows has a utility, so does the Mac. But you can buy third-party software that'll do that too. But you should back up your documents, your databases, whatever you want to back up. You cannot, it's difficult to back up software this way because you have to install it. That's different than just restoring it. But your data, documents, all those things should be backed up. So if your hard disk crashes, and it does happen, you can just go, oh, well, I just need to get a new disk, install the software, and I have all my data backed up. Many people, and I am one of them, have moved to the cloud, the internet cloud, to do my backups. I have a service I pay, I guess, $50 a year, and I have unlimited storage. And it runs in the background, it's a background process. And whenever I write or change a file, it backs it up to my server in the cloud. My disk crashed tomorrow. I have all my data out there in the cloud. And I can go to another computer, buy a new computer, install the software, download the software for this application, for this service, type in my user ID and password, and download my data back from the cloud. No big deal. And I never back it up. It happens automatically in the background, constantly. Now, you can set it up to just do backups once a week. And I tried that, and it sometimes takes so long to do that, your system runs slowly. So I changed it to have it do it continually. Whenever I change something, it just puts it up in the cloud. You might be interested to know that Amazon has a huge cloud storage business. Netflix does all of their movie streaming from Amazon cloud storage. So Amazon and Netflix are really, and Amazon is learning from doing business with Netflix, and they're starting, well, they had it for a while, their own streaming business, but they're also charging Netflix for this other service. So you might think about that. It's nice to not have to think about it. Number one, it's automatic. Number two, if you have a backup, you don't have to find your backup disk. You just buy a computer, plug it in the internet, and download your data. And then restore, of course, is just the reverse. Screensaver, you really don't need those anymore. With cathode ray tube, CRT monitors, you needed them because, believe it or not, if you left the same image on there too long, it actually would burn it into the phosphorus. It would never go away. You would see that image forever. So the idea behind screensavers was that if you keep refreshing the CRT change the image, it never gets burnt in. And that's how screensavers started. Well, modern LED computers don't really do that. Different technology. But people still like them and they use them. I use screensavers. I love it. Firewall, that's security. Most operating systems come with one. Most people that are serious about it buy their own. But for a home computer, I think Windows Firewall is just fine. But for our servers here, of course, we have much higher level McAfee corporate business software. You might think about doing that. And of course, firewalls are software, and actually sometimes they're hardware that stand between your computer and the outside big bad world, dangerous world, and decides what comes through to your computer, and you can just tell it what to let through. Corporations are using this now, actually, firewalls, to limit what people can do. My wife works at a place that had a consultant come in, and their firewall now blocks Amazon and most email services. So when you go to work, you can't check your personal email, you can't shop. And I guess that kind of makes sense. Some people don't want their people to do that. I can tell you when I worked at Kinko's, the owner wanted people to do that because he felt that it reduced the stress for the workers to be able to communicate with family and take care of things on the internet they needed to take care of. The point is, the firewall lets you do whatever you want to do. And most places now use the firewall to track where you go. So if you're at work browsing to sites you shouldn't be browsing to, there's a log somewhere of that. So just keep that in mind. And normally they don't go through those logs till there's an issue, and then they go back and see what you looked at. So keep that in mind. And then there's also programs that protect you from malware, is the term that encompasses all of these things. And we'll talk more about these when we do the lecture on security. But quickly, this is code somebody writes and somehow puts it on your computer and does damage to your computer or sends out things to other people. That's what a Trojan does. So Windows has one called Microsoft Security Essentials. And I don't know whether this just started. No, it was before Windows 7. It's free, and we use it, and it works really well. They update it often, and it takes care of viruses. And if a virus pops up, it blocks it normally. It has a database of viruses. So you need some kind of virus program if you do a lot of things on the internet. I wouldn't just assume everything's okay. All right. We'll talk more about this when we talk about security. But most operating systems come with something is the point. And spyware and adware are similar things. Spyware is spying on your behavior. Adware makes things pop up and tries to direct you to places. Normally these things aren't doing anything to your computer, but they could be. They're taking resources, RAM. Remember, this is a program, so it's going to take RAM. And it's taking your processor. It's programmed. It has to have processor. So those two things, the utility programs might take care of that. Here are some others. This is security. Point is, your operating system probably has security. File compression utility. Most operating systems will compress your file. What does that mean? It means it takes out redundant code. It tries to remove patterns in your bits, zeros and ones, and reduce it down as small as it can. Now, you can't read it or look at it that way, but if your files you don't use often, it can save some disk space if you compress it. Windows will do that for you if you tell it to. Microsoft Office will do that, especially Outlook will compress your old email. If you don't look at it very often, it's fine. The only thing is when you do look at it, it has to uncompress it before you can see it. But just another thing to think about. A media player, you know what that is, plays your music, your videos. Most of us don't use what comes with Windows. We use something else like iTunes. I use Spotify, occasionally iTunes. And software allows you to burn disks because Windows doesn't really, it has one, but it doesn't work very well. Most people get a third-party one to do that. Maintenance utility, which allows you to schedule all these maintenance things I've been talking about and adds a few more on top of it and helps you make decisions. I don't use one of these, but many people do. Okay. So we've defined an operating system when we've talked it to death here. It's the software that allows you to interface with a machine. All right. In other lectures, we'll be talking about input, output, programming, all the things I discussed here. So let's look at those lectures and be sure you look at the forums to see the assignments. I'll give you there's some videos I want you to look at. I do have one video that shows the very first demonstration of a mouse and a GUI in a hierarchical structure of just like you use in Windows back in the 60s. And the guy is in San Francisco, the computers are in Southern California, and he's wearing a headset. Of course, it's black and white video. And he's doing a demo of how that all works, which is, of course, years before Apple. And it's the people I was talking about earlier. They developed this stuff. It's very interesting, and there'll be other things. Look for out there in your assignment. All right? Thank you very much.